So how did we get there? We saw a few 3D examples of some buildings. They were pretty models, and they were hopefully all fit for purpose, and they had been generated using exactly the specification that had been defined prior to them actually being started. The question is, how did we get there? So what's the current practice, and where do you source models from? How many should you have? Whether you should be running parallel or single models, and how that process is established. So let's look at the current practice. First of all, let's ask the question, where do we get our models now, and where will we get them in the future? Is that likely to change? It's something that we have experience to say that it is a transition. We cannot necessarily start at the end of this path. We do need to gain experience as we go through and understand how that we can specify in order to hopefully have one person creating one model, or essentially lots of people creating individual models without overlap, and being able to manage and merge those in a progressive and a collaborative way. You might not at the moment have any modeling. It might be very fresh to you, and this is to say that there is a starting point that we can recommend, but essentially you might be at the other end of the spectrum and have everything in-house and be questioning how we can work together with the A&E teams in a more structured fashion, and hence model progression specifications again will solve many of your problems. We can also have an outsourced approach where we would specify and request somebody else, a third party, to create the model and to manage it. Or we can have the opportunity, Vico offers our back office creation and management services under your control. So we would be able to train members of your staff in order to make them proficient to manage our back office teams and to gain modeling inputs at a very low cost. We can help design teams, and we also have the opportunity at the end to say, let's source all of our models from the A&E team. And there are different combinations, and there are different pros and cons to each of these approaches, and we'll elaborate on them as we go through. Huge amount of debate. It's actually one of the, I think actually two of our most popular blogs are about this subject. How should we create our models is one, but how many should we create is another very, a question with potentially many different answers. Everyone would like to bring their own model and create it in exactly the way that they would like to, so that it's most useful for them. But they don't necessarily all play very well together. So what's the optimum solution? How do we ensure that whether we're running parallel modeling or whether we're running a single model, it's the best solution? What is the best solution? I always like to coin the phrase from our CEO, Mark Sawyer. He said, why use one model when 5 will do? And I think it's such a great phrase, the irony there, but the truth in that, essentially saying that sometimes it might be better. It would be great to use one model, and from somebody without a huge amount of experience, so not Mark obviously, but somebody from the outside, saying, looking at the process, and as an owner potentially not being BIM savvy, they might quite easily desire a one model approach, but not understand how difficult that really can be and what the problems are that need to be overcome in order to achieve that. So we'll talk about that some more. So I mentioned parallel versus single modeling. Parallel modeling meaning within the same team we will have, not meaning within the same team that we'll have duplicated effort, but we might duplicate the effort in between teams. So if the designers create some model and the construction team creates some model or models and the subs create their own, essentially there will be duplicated effort in many of those models, and it might be good because the construction team can create their models in the way that they would like and maybe not add necessarily detail in the areas that the design team would, and vice versa. But we would love it if we could just use one model and remove all of that effort. So the problems with running many different models is that we have to maintain them all. We have to look very clearly and understand how we're going to manage the versioning, how we're going to try and synchronize those models, and if somebody is requiring input from another party's model, for example, the construction guys creating their model from some of the design inputs or a lot of the design inputs, it's going to cause us a delay when we're synchronizing. So we're not necessarily going to be always up to date. It might be 2 or 3 weeks behind, and that can cause us some problems. So the single model approach can prevent a lot of that duplication and prevent the delay, and hopefully reduce the amount of work that's wasted in that duplication of the effort. However, that sounds like the best approach. It sounds like something that everybody should be doing. However, on the parallel side, if we're creating models for individual purposes, there's lower amount of change in the process that's required, and therefore easier to implement. And as I said there, it's an opportunity for us to build a model fit for its purpose and without redundancies, without huge amount of effort and potentially some rework because of that desire to use a single model. So however, for the single side, it's just a huge process change that's required, and we are moving closer and closer, and having the MPS is a significant step to support that process change. So implementing what we'll see later as the model progression specification, it's a way of everybody talking the same language and everybody specifying something and understanding what they're going to get before they get it. So if we looked at a single model, if we looked at one model that is trying to produce all of what we can see here, so everything from 2D documentation to the quantities required to understand the resource demand, to create cash flow, to create our 4D simulation, not to forget our constructability analysis as well, and there are many others. Essentially, trying to fulfill so many possibilities, it's an extremely difficult task. So we can try and aim for a single model, but potentially there might be redundancies in certain areas for certain parties, and it might not be as easy to work with somebody else's model if it hadn't been predefined and you had known before you were going to get it what you were going to get. On the parallel front, so what we're seeing at the moment, most popular in today's market, is that either the A&E team is just working in a traditional 2D fashion, or they're working and using a 3D model and generating backgrounds for the 2D information, and then the construction management or the GC would then use those 2D outputs from either the traditional or from the 3D to 2D and create their own parallel construction model fit for their purposes. So generating a means and methods model for quantity takeoff, for cost planning, for schedule data, meaningful location-based quantity data, and therefore more accurate and integrated practices within their own organization. But what's becoming more and more popular is that everybody would love to use a model that has been created already. So if the A&E teams are being a lot more progressive and adopting BIM and creating at least the architecture and structure from an early phase, then creating whatever 2D data that they need in the 2D and not actually necessarily creating 3D elements for all representation in the 2D documents. And the GC CMs are then having to fill in the gaps potentially. There could be some reworking of those models, and we'll talk about that in a minute. And also, we're trying to substitute, replace some of the model data by having subcontractors to create their, mostly the MEP trades creating all of their models. So we're moving, this delta is moving us from the parallel to the single modeling approach.